And that's likely to be the effect it will be. That's what we're basically going to do next month. I'm going to generate an Android app and a REST API, and it's going to be a horoscope app that we're going to do because DALL-E is really good at doing zodiac signs. So that's going to be next month. But this month's topic is the Cyberdog. So we're going to talk about the Cyberdog. And the goal next month really is to generate the entire app without writing any code. I may have to use GitHub Copilot, but I don't think I will have to. Okay, so why use AI and robotics? Well, first of all, I wanted to use them for good instead of evil. I've seen a lot of stuff out there that's, showing robot dogs in as kind of menacing things for police forces. And I think that there's lots of positive uses for this instead of the negative uses. So, for example, if you're in a situation where there's, in a school where there's been a shooting, in a city where there's been some sort of event, to get the first responders there now, if it's going to be a large casualty event, I think it's going to be pretty difficult. So, and then even something as simple as we just went through the pandemic, so it would have been really cool if we could have had cyberdogs out talking to people so that they wouldn't have any risk of getting infection. So, you could basically see how bad the person was, have a chat with them, and then figure out what the next steps were. So why do we use it? Well, scalability. So you can have multiple cyberdogs assess many people simultaneously. Safety, so it reduces the risk for human responders. You probably heard about the weird stuff that happened with FEMA this week, where people were shooting at FEMA in North Carolina, which just strikes me as amazingly bad. So if we have dogs, well, maybe that would be a way for us getting to areas where to reduce the risk for human responders. We want to make sure that they're kept safe. Also efficiency, so faster medical response times. The dog currently goes about 3 meters per second. So, and they're actually really resilient because we had them when we were doing the challenge and they were walking over very unsafe terrain. We tried, basically the reason we went for dogs is because we were using a little rover, a little robot car, and it just didn't work because it couldn't go up hills. It would get stuck in puddles, all this sort of stuff. One of my memories when we were doing the challenge was the dog got its leg wrapped around a piece of wire that was as part of the use case that we're doing, and it just basically brushed it off and kept on walking. So it's pretty amazing. And then the accuracy, so you can get, we didn't do it for the challenge, but this is kind of in the next steps, is to kind of get, we can fly drones really easily automated. And then I want to be able to do the same with the Cyberdogs, and they do talk ROS, which is the robotic operating system. So there shouldn't be any reason why we couldn't get the drone to fly over the area, identify people that need to be triaged, and then basically send the dog over. Obviously, there's lots of ethical issues in here too as well. How you choose who's good and who's bad, I would leave that up to the first responders. We're just collecting the information. We're not doing anything else. So what is the challenge for the first responders? So they have immediate needs, urgent calls, critical assessments. That basically they need to get out there as quick as possible. If you could have lots of different dogs doing this, then that would help. Drones are great for an overview, like the 400-foot view, but when it comes to actually figuring out what's happening on the ground, they're not great. And then first responders are stretched thin, they need support, they need information. So basically what we're trying to do is bring all that information together. And then you can have automated assessments. So basically what we're going to do is I'm going to give you all the code to show how if you do have a Cyberdog, you could basically run it, but you can still run this code on a laptop, on a Unix laptop, because essentially that's what's running in the operating system of the dog, and then use a server to send that information back, and then you can use ChatGPT to figure out what's been said. So we have a bunch of recordings that we play, and then the person responds to that recording, and then we take that information and pull it back to the operator office, i.e. our laptop. And then what we do is we use ChatGPT to take that and transcribe it into text, and then we use another ChatGPT to summarize it. We did Whisper in, I think it was the second or third meeting that we did, and so we're basically just using the same technology. Whisper is an OpenAI API. Okay, So again, we're going to get the dogs to navigate dangerous areas so they can get into inaccessible locations. You've probably seen a lot of the videos with the dogs doing flips and stuff like that, but they are actually pretty nimble. They will go up and down reasonably steep gradients, but not. They won't climb up walls or anything like that. That's not going to happen, not yet anyway. And then we can, because we're able to get this RTSP feed, which is just basically a video and audio link. We're able to take that back and remotely, and we're able to use Whisper, which is an OpenAI API, to analyze the audio to identify urgent needs. And then hopefully somebody with better credentials than mine would be able to triage the responses and identify where the human should go out to first. Okay, so this is I took a picture from the website that I was just showing at the start of this, which is the DARPA challenge, where we did this challenge. So this is from the competition, where this is the dog that we were using, and it's the Xiaomi Cyberdog 1.0, which is got an NVIDIA Jetson on it, which is super cool. Also, the price of them. So the price of the Boston Dynamics dog is $75,000. So the price of the Cyberdog is, we got it from a friend, Kevin. Thank you very much, Kevin, for $2,500. And there is a Cyberdog 2 that's out now that looks very much more like our furry friend over here, rather than the Cyberdog, the 1.0, which is kind of menacing. But it's we don't have one yet. I think they're about the same price, about $2,500. So orders of magnitude cheaper than what's available. So we're seeing on what's known as UGV, which are the unmanned ground vehicles. We're seeing the same as the UAVs, which are the drones. So the Chinese stuff is much cheaper than the US-based stuff. But there's just no way that we can afford 75K to do this just for research purposes. So the Cyberdog is nimble enough to perform backflips. I wouldn't recommend it because those little legs break and you only get a couple of extras. It can have payloads too as well. So you can put all sorts of things on this. You probably can't make it out here, but we have a e-stop here where we can turn it off. You can connect, you can connect a LiDAR sensor. You can connect all sorts of different things. And it's got a lot of sensors in there already. So it's already got lots of different cameras, lots of obstacle avoidance. And its max speed is 3.2 meters per second. I think I said that. And then that's kind of twice what Spots is. And it also has a Jetson Xavier AI platform. So it's got a GPS module, an ultra-wide angle fisheye lens. It's got a RealSense camera, Intel RealSense camera in there. And you can access all the different cameras. It's controlled very much like a drone is, where you have a mobile app. Basically, that's how you make everything work. So there's an APK that you get, you put it on your phone. It's an Android phone, and off you go. But it also speaks ROS 2, which we're planning on using in future applications. The Cyberdog 2 definitely looks much more like a dog. And if we do get one of them in the future, I'll probably do a talk on that later. So how is this all going to work? Okay, so here's the flow. So we have to create the questions. So we're going to basically use Whisper to do text to speech. And then we are going to copy them across to our Cyberdog. And then on the Cyberdog, what we're going to do is we're going to do data capture. And the way that we're going to do that is because it's a Unix box, because it's got all these sensors, it has a microphone, it has a speaker. It's kind of creepy when it starts because it's pretty loud and shouts at you in Chinese and Mandarin, which can be very disconcerting. But great for us because that means we can do whatever we want. It can play whatever languages that we want. So we have an RTSP feed, which is video and audio. We play the recordings that we did in step 1, and then we give the human 10 seconds to answer each of the different questions. We take all that information back from the audio feed onto our laptop and to our operator station, and then we use Whisper to transcribe that audio to text. So basically what we're doing is text to speech of them. Sorry, are we doing that again? They're all going around again. I am. So we're doing speech to text in this case. And then I have just a simple prompt, which basically asks ChatGPT to summarize the conversation. You could put a lot more in there. You could give examples about what was a good response. You could give examples of what was a bad response. But I'll show you what the code is later, so how that works. We're just going to basically analyze the text to determine the person's condition. And then we just give that text off to whoever the first responder is, or the nurse, the doctor, the paramedic, to be able to make a decision about what they do next. It's pretty hypothetical at the moment. So these are the questions that we chose for our little competition. So are you having trouble breathing? Is there a lot of blood? And then where is the blood? Where does it hurt? And then can you move your arms and legs? So we're basically looking to see if they're still breathing, if they're bleeding, or is there pain? Are they incapacitated in any way? This could be anything else. This could be somebody talking to somebody in a different language. So you could do Spanish, you could do French, you could do whatever language you want. Because I think there are about a dozen languages that OpenAI Whisper does at the moment. So any of the languages that are available, you could do that. So here's what the Whisper code looks like. This code's changed a bit since we did it last July. That's one thing that I've noticed a lot in OpenAI, is that it's a rapidly moving fest of APIs. So the thing that's changed is we basically have to do, before we did, there's kind of a theme with each of the different APIs. So it's OpenAI.chat, OpenAI.audio, OpenAI.image, OpenAI.moderation. So they all have this kind of thing. So in this case, what we're doing is we're taking this text, which is, are you having trouble breathing, which is our first question. And then what we're doing after that is we're just turning that into our speech file. So we have a whole bunch of different recordings that we've done. We play them on the dog, and the way that we play them on dog is pretty straightforward. They're just one after the other, but there's no reason why you couldn't write a script to change the questions based on what the answers were that were coming back from the dog, but we didn't do that in this go round. Okay, so how do we get them over to the dog? So here's what the dog looks like from the top. So it has a HDMI port if you want some output. It has a charger for its batteries. It has extensions for other sensors. So if you want to add anything on top of it, so if you want to put a LiDAR or something else, or a USB, and it has a download port. So that's cool. So basically what we do is we connect to the download port, and then we use a thing called SCP, which is just a Unix command for secure copy, to copy the code over to the dog over this USB port. And really, essentially, that's what we need to get going. So we're going to need, if we go back here, we're going to need the recordings. So whatever the recordings we did in Whisper, we're going to need the code that's going to be able to set up the RTSP server. And most of the code that I got, I basically just asked ChatGPT to do it for me. It didn't require a lot of effort on my part. I don't speak FFmpeg, so when I want to do get the audio and turn it back into something that Whisper can translate into text, I just basically asked ChatGPT to do it. And same with the RTSP. I said, can you, I'm on a Unix box, can you give me an RTSP server? And then just ask what libraries I need to install. It was pretty straightforward. Okay, so this is the code, and I have in the resources, I've given all the code. Basically, on the dog, we're running an RTSP server. Because the dog is running on a Jetson, it's an Ubuntu box, and we can just SSH into it, so shell into it, install whatever packages we want once you're on the same network. You don't even need to use the download to do that. So the code was largely generated using ChatGPT. The only thing I would say in the code here is you have to change a bunch of things. Whatever your IP address is, the video device is 5 for the camera that you want, which I didn't update the code. I'll have to do that. So the Python code sets up a RTSP, which stands for real-time streaming protocol. So it streams video and audio from the /video5, and it uses the GStreamer library. So the video streamer class is responsible for creating the GStreamer pipeline that captures video for the video device and the audio device. The doCreate element constructs a GStreamer pipeline that specifies the video and audio sources. Again, like I said, I got this from ChatGPT, just asked it for it. And then the server class here initializes the GStreamer library and sets up the RTB server. So it sets up this video stream server. And it creates an instance of the RTSP server with the right IP address and the port. based on what we put above. So you'll have to change the IP address for whatever the dog is at the time. So what is it? IP -H, or hostname might get it for you, or just IP in its own sometimes. And then the factory is responsible for handling requests to the video stream endpoint. Okay, which is basically what we do is we just connect to, once we set this up and run it, we can use VLC to connect to the RTSP stream and just make sure everything's working from the laptop. Okay, so then the next thing that we want to do, and this is the world's simplest bash script to play a recording. So basically what we have is we have 1, 2, 3, 4, 5 recordings, and I just play them one after a time. There's no intelligence here. I'm just giving it 10 seconds to wait between each of the different scripts, and then it's just basically playing each of the different files that we created, which are you bleeding? Can you move your arms? The things that we talked about a little bit earlier. Okay, so now we're on the operator side. So this is basically the laptop. So it's connected on the same Wi-Fi network, and we need to capture the audio. So we got to record the scene's audio feed. We want to start recording the question and answer session. So the dog is asking the questions, the human is responding to it. We're getting the audio from the microphone. It's been passed back to us. And also we want to handle the shutdown when the conversation ends. So we want to make sure that's working. So to start recording, what we want to do is use FFmpeg. So I need to update the resources and put it in, but it's ffmpeg.org to download this. You're just going to make sure that it's installed on your laptop. You can either use it from the command line or from WSL, Windows Systems Library, or from a Mac. You just have to make sure that you have ffmpeg installed. So this is grabbing the stream. And then there's a bunch of different libraries we got to install. One of the main ones is Soundfile. So we're using Soundfile to save the stream to a file, which we're just going to call recording.wav, which is going to be on the laptop and not on the Cyberdog. So we have all the other recording files on the Cyberdog, and this is the one that we're saving locally. Again, all the code is up in the repo, and I'll show you that. So you'll have to change the RTSP URL and name of the audio file for whatever you want. Okay, so then we have two things that we still need to do. So we need to do the speech to text on the recorded file, and then we need to summarize the text so that we can see if a human needs to go and visit. So here's the speech to text part, which does like I said, they're all kind of the same kind of theme. We have OpenAI.audio, transcriptions create. If you haven't looked at any of this stuff for the API, the first thing that you have to do is go to Playground to get yourself an API key. The way that I do it, not everybody else does the same, but the way I do it is I always use config. So I import the config library, and then I have a file called config.py, and then I just put my key in that. That's not up on the repo, so you're going to have to get your own one if you want to play with this. And then what I'm doing is I have the file that I took from the RTSP feed, which is called recording.wav, and I am using the Whisper 1 model, and then I'm just basically outputting the transcription. If you do import Whisper here, that means you're using the offline version of Whisper, so that could be pretty cool. You could do offline Whisper too as well. Maybe you're in an area where you only have a network between yourself and the dog, and then you don't have an external network, so you could use an offline Whisper if you want to. We didn't get around to doing that, but that was something that I thought would be useful for rural areas. So you can see the transcription here at the bottom. Are you having trouble breathing? Yes, I'm having trouble breathing. Is there a lot of blood? Yes, there's a lot of blood underneath me. Where's the blood? Blood on my legs, underneath my body. Where does it hurt? Hurts on my legs and arms. And then it says, can you move your arms and legs? I can move my arms and legs. Okay, so the last thing that we want to do is we want to take that information and put it in a summary that somebody can understand, rather than having to just run through a whole bunch of things. So we have here the patient is having, at the end, when we summarized it, patient is having trouble breathing, and there's a lot of blood underneath them, especially on the legs, underneath their body. They mentioned that it hurts on the legs, arm, and head, but they're able to move their arms and legs. So based on whatever questions that you ask, you can then, and whatever system message you have here, you can turn it into something a bit more descriptive. Maybe, you could basically We do some examples where we take a transcription from a customer service rep. There's a classic one that everybody's using, which is kind of when you call Comcast ISP, and what you do is you're trying to make sure that the person said their name in the first 5 seconds, was polite, introduced them, all that sort of stuff. And then you can take metrics from that. So it'll give you a CSV file. So there's no reason why you couldn't have a much better array of questions if you knew what you were doing, if you were clinically trained in this area. And then you could come up with a much better description about how you would triage the people to be able to get a much more accurate metric on whether, is this the person that we really need to go to see immediately, or are they on the cusp and they can wait 15, 20 minutes, and we'll go see the people who need to be triaged first. But basically the way it works, so the second part is we are passing in the transcription. So that's the thing that we just got here. So that's from the recording.web file. We have our system message, which says you're a helpful first responder who is trying to see see, even my English is wrong. How many people are in need of attention? Here are the questions we ask the patient. Are we having trouble breathing? Is there a lot of blood? Summarize the conversation if you can. Only use the responses. You got to tell it not to take information from outside our little ecosystem here, because it'll try to pull information from what it was trained on the LLM, and we don't want to do that. We want to keep everything safe here. Okay, so again, what are we doing is we're started off by playing the recording the pre-recorded questions. We're going to play those, and then we have the data capture. So we get our RTSP feed, which is sent back from the dog to the remote operator, which is on their laptop, or they could be anywhere. They could be in a different city. Could be once you can get an RTSP feed over the internet, you can be anywhere. We could get, but then what we do is we get Whisper to do the transcriptions. We transcribe the audio to text, and then we get ChatGPT to do analysis to give us some sort of a metric to determine the person's condition. And then I'm not qualified to make a decision. That's for paramedic or doctor. We're just providing with the information. So there's lots that we wanted to do as well, and we never got there yet, and maybe we'll do later. So what the general plan is at the start for our competition was we were going to use a drone to survey the area. Drones are great. Basically you can just do an automated flight plan over a small area in a couple of minutes. You can use object detection. You can use a thermal camera to see where the people are. You can get a general idea about what people are, how much they're bleeding. If they're missing a limb, that sort of stuff. So there's lots you can do from the air. And then what we want to do is basically send that information to the dog and get the dog to automate a path. It's really easy to automate it for a drone because there's nothing in the way. It's a lot harder for a dog. So we want to make sure that we can get leverage ROS to plan the dog's route to get wherever we need to get to as quickly and as effectively as possible. And I'm not sure why the AI put I think that's the Cyberdog, why the Cyberdog is flying here, but as with everything, the AI is never perfect. Okay, and I have a bunch of resources here. So I'm going to walk through them in a second. So we have I put a playlist up for each of the different talks that we've done so far for this meetup, for OpenAI Explorers meetup. And then I'm also teaching a course on using OpenAI and ChatGPT, which I'll be adding to every week. So that's the second playlist. I've got 3 or 4 of them up already. This is a document from The Verge, which talks about basically the specs of the Cyberdog and tells you all the things it can do. It's pretty old now, so you can see it's from 2021. So the dog is 3 years old now, and the Cyberdog 2 is really where all the action's at. But what we're doing here, the Cyberdog 2 also is using a Jetson, probably a better one than what we have, and it's still on a Unix stack, so there's no reason why we couldn't do this. And then the code that I used is here too as well. So let me just go through a bunch of different things. So this is, people are putting all sorts of different things on their dogs at the moment. So the effort to be the laziest person in the entire universe. But between drones and dogs, I really think that they should take away all the boring jobs that we don't need. So a couple of people have put all sorts of different things on it. I've seen some Halloween ones that I think are really funny too as well. So lots of stuff on Twitter and Threads if you want to check it out. This is the DARPA challenge that we entered, which was kind of the systems competition, which was a few weeks ago. That was great fun. Really enjoyed that. Just some pictures of the Cyberdog. Let me just cut it back a bit to just show you what it is. So basically this is the way it looks. Kind of walks a bit clunky, but it really flies when it needs to. And it's kind of waterproof, got lots of different sensors. What else is it going to show? You can see if I stop it there, you can see a lot of the different cameras there. So when you're looking through when you're using the APK, it's basically using this to show you where you're going. But what was really good for us was when we were using the RTSP, we were getting access to the cameras down here, which is much more appropriate because we're looking at people who are typically on the ground, lying down. So that worked out really well too as well. I did want to show you Canvas before I went to as well, because if you haven't played it yet, I think it's absolutely amazing. So basically, if you go to ChatGPT now and say, I want to use GPT-4 with Canvas, which means you have to have a paid one. And I've asked it to do all sorts of things, but basically what I'm asking it to do is to create Android activities for me. So it does, the linear layouts, does all the stuff, does the Kotlin, all sorts of other things. And also, I did a lot of the RTSP code in here too as well, but it was before Canvas. Here's the meetups that we've done so far. If you want to go and have a look at those in the past, here are the playlists for the class that I'm giving at the moment. So I'm going to be adding lecture 4 over this weekend. I started doing this gamma.app because I think that the slides are just so much better than the crappy white ones that I had in the past few months. So if you go back at this playlist, you'll see my not so good slides. But I'm going to use this for the moment because I think it's pretty good. And then I put the code here, which is in the resources, and I will put the slides up tomorrow, and the video is already up there. And then I just want to talk about the code for a little bit. So let's see what we have. So the first thing that we did was record questions. Let's make the code a bit bigger. So really straightforward. Whisper is, this is about a 2-minute job. One caveat, of course, if you haven't been following us, you can't ask ChatGPT to generate code that uses the ChatGPT APIs because it was trained up till November 2022, and all of the APIs have changed since then. So irony of ironies, ChatGPT is terrible at generating code for using its own APIs. So the way to do it is just go to Playground and look at the docs, and then there's lots of examples they have on GitHub. But this is pretty straightforward. So we're saying, give me from this recording. Basically, what I want to do is, here's my input. Are you having trouble breathing? And then I want to put it as recording 1. And then it's using this text-to-speech model. There's lots of different voices that you can use. They're all kind of mid-American, male, female. We went with a female voice because we thought it'd be friendlier. And then I think we did anyway. Let me just run this and see what it sounds like. Okay, so recording 1.wav. Just play it. Hopefully you can hear it. Okay. So pretty straightforward. So that was the first one. So that was recording questions. The second one that we did was set up the server. So this is kind of complicated. So this is setting up the RTSP server. You got to make sure that you have, this would be 5 for the dog, whatever the IP address is, the dog. The port's always going to be the same. And then it should tell you at the end that the RTSP server is running at this. And then if you go over to your laptop, if you're on the same network, you can look at that using VLC. Okay, what else do I have here? So then I want to be able to listen to what's going on the other side. So I would go back to here, whatever my IP address was. Oops. Okay, so now I'm pointing at the right server. So I just want to have a one recording.wav file, which is whatever I'm getting from my audio feed. I set up my FFmpeg to be able to capture the audio stream. I start recording using, and then I'm saving it using sound file. What imports do I have? I have sound file, that's important. Signal, that's important. And threading, that's important. But most of the other ones you're probably going to have anybody already installed. So pip install sound file will get you where you need to get to, plus the rest. Then after that, we have this file, which is recording.wav, which is, so it's basically the questions and answers. And then what I want to do after that is I want to transcribe that. So I'm going to use the bad one first. I'm also going to fix this because my English is wrong. Your helpful first responder is trying to see how much a patient doesn't need attention. I should get ChatGPT to write this better for me. Okay, here are the questions we need to ask the patient. Okay, so and I'm going to print out the transcription as well, just to make sure that you can see that. So this is using Whisper, and then it's using ChatGPT. So this first part is the question and answer that I got from the dog, and the second part is the summary. And then we'll do the same with I have a recording good, which is just somebody saying, no, I'm fine, you don't need to come talk to me. To show that it's working in different cases. Okay, I think that's it. I don't think I have anything else. Anything I forgot to show? Nope, that's it. So I'm going to stop presenting now, and then I'm going to see if anybody's got any questions. Yeah, if you hit this QR code, you can subscribe to our blog list, because we've got quite a, basically what we do is we take each of the different talks that we do, and then we put them up on YouTube, and then we create a blog. Let me show you the blog for all the stuff that's out there. Of course, Michael does a great job using ChatGPT to do that, so we're not doing it by hand, because why would you do anything by hand these days? Actually, I'm really excited about the code generation one next month, because I'm just amazed how good it is, and I think it is going to blow away all those no-code apps that are out there, because there's Bubble and a few others, and I think I would disinvest in them immediately if you have any money in them, because I think they're going to blow up, because the no-code is just, the code generation is so strong at the moment between Claude and ChatGPT that if you know what you're doing, if you've built one or two apps in the past, then they're streets ahead of what you can get from no-code platforms. Okay, I'm sorry, I'm rambling. Any conversations? Any questions?
Yeah, hi. I'm trying to visualize how this all works in actual world. So the cyber dog you said would go to someone in distress. So the recording device on the cyber dog would be able to stream this file to the server running somewhere, or how does it
Yep.
work, or does cyber
Let
dog
me just
come back? Yeah.
show you where this is what we did when we were doing the challenge. So here we had, so basically they had a bunch of dummies that were set up, and they had all these boxes with QR codes that that showed you who the different people were. So basically what you're supposed to do is see if each of the different people were in need of further attention. So the Cyberdog is on the same network as the drone and on the same network as the laptop. Cyberdog is a Unix box that moves. So the RTSP is running on the Cyberdog, and then that's passing the RTSP feed back to the laptop. So because it's a Unix box, we can get it to ask the questions. So it basically, we just run a bash script to play the different WAV files. It plays the WAV files, and then the person talks back to it, to the dog. Because we have an RTSP feed, we're taking that feed, and then we're passing it back to the operator. So normally, if you weren't using ChatGPT, the operator would just hear what was the conversation with the dog. But because we have ChatGPT, we can basically use speech to text to do whatever we want with it. So we can pull it back, leave it in a file. We can put it in a database. We can put it in an Excel spreadsheet. We can manipulate it every way we want. We can change its language, that sort of stuff. Does that help?
Yes, that helps. So in this case, you would also need connectivity to the internet since you are calling the ChatGPT API.
Well, yes and no, because there is an offline whisper. So the way that we had it here, there was connection to the internet, but you don't need. If you there's an offline whisper, so if you download the model, you can basically get the transcription going. You wouldn't be able to do the summary, but you could definitely get the transcription from the speech to text.
Yeah, I think
And then
that
you
helps.
could, and we could probably use Llama or something else to do the summary. You don't need, like I'm using ChatGPT 3.5. It's not like we need the latest and greatest OpenAI model to do transcription.
Yeah. Yeah, I think that helps because I was visualizing a scenario where, like, say you are reaching out to someone stuck in a cave, like those boys were
Yep.
stuck in Thailand. And yeah, I think this will be a very helpful thing there. Yeah, thank you.
100%. Thanks for your question. Sorry if I didn't clarify that better. Anything else?
Hi. I was just wondering where the resources were going to be. Were you going to send out an email or?
I always put the PowerPoint up on the meetup. So if you signed up for the meetup group, the PowerPoint will be up there tomorrow.
Okay, and what about like the links to the code and everything? That's in the PowerPoint.
Yeah, it's in. Okay. It's right at the very last one. I'll show you.
Okay. Awesome.
Or if you just want to go to it now, if it's if you go to github.com, my name's, which is here, I'll show it to you, Godfrey Nolan. I did that very quick. You can find it there. Okay. So just here, this is where everything is.
Okay, cool. Thank you.
And if you have any issues with the code, if you have any problem with it, open an issue on GitHub because I will respond.
Okay, cool. Thanks.
All right. Okay. Anybody else? Nope. Okay. Thanks very much, guys. Hopefully see you next week when we do code generation. I'm really looking forward.